again, this time section 8.2, parallelograms. We started to talk a lot about the different types of quadrilaterals that we have in geometry. The first one would be the parallelogram. So what is a parallelogram? Well, it's a quadrilateral where each pair of opposite sides are parallel to each other. So in the diagram here, we've got a quadrilateral ABCD. You can see that segments AB and DC are parallel to each other. Segments AD and BC are parallel to each other. So both pairs of opposite sides parallel to each other. That's what determines a parallelogram. Now the nice thing is there are lots of different properties with parallelograms as well. The first one says that both pairs of opposite sides are congruent. So if I have a parallelogram, the top and the bottom, those two segments will be congruent to each other. So in this case, AB is congruent to DC. And the left side and the right side will be congruent to each other as well. So in this case, segment AD will be congruent to segment BC. So both pairs of opposite sides will always be congruent in a parallelogram. Class is over. Not yet. Both pairs of opposite angles are also congruent inside of a parallelogram. So angle A will be congruent to angle C. Angle B will be congruent to angle D. Consecutive angles are also supplementary, meaning if I'm looking at angle A, that's going to be supplementary to angle D or angle B. If I'm looking at angle C, that'll be supplementary to angle D or angle B. So here I've got some lists written out for you. Check that out real quick. Back again. So consecutive angles will always be supplementary. Fourth property. If one of the angles of the parallelogram is a right angle, then all four angles will be right angles as well. So in this case, if angle A was a right angle, then the other three angles would be right angles. So you'd have something like a rectangle or a square possibly. Our fifth and final property is that the diagonals of a parallelogram bisect each other. So in my parallelogram, if I draw a segment from corner to corner each way, those two lines will be considered diagonals, and they're going to meet at some point. In this case, I call it point E. That point E is the midpoint of both segments, so they bisect each other, which means that AE will be congruent to EC, and then segment DE will be congruent to segment EB. So now we've got a couple of different examples to take a look at. And this right now, if you wanted to pause it, might not be a bad time. Kind of write everything down real quick and then we can see how all this stuff comes to fruition. So, here we've got a figure, quadrilateral ABCD, that happens to be a parallelogram. You see we've drawn in the diagonals. Here angle DAB, this angle up here in the left corner, is always going to be congruent to its opposite angle. So down here we're looking at angle DCB. Segment EC, which is part of one of our diagonals. Alright, again the diagonals bisect each other, so EC will be congruent to segment AE. Angle CBA plus some other angle will equal 180 degrees. So we're talking about supplementary angles. So that means we need to find the consecutive interior angle to CBA. Well, in this case, you have two options. You've got angle BAD, this guy, or we could also use angle BCD. So this angle and this angle will both be supplementary to this angle in the top right corner. In example 4, segment AD, opposite sides are congruent, so it's always going to be congruent to segment BC in this case. Angle CAD, right up in here, okay? Right up in here! You've got parallel lines, so these diagonals, while they bisect each other, they also act as transversals. So we can go back to this idea of alternate interior angles. So angle CAD will be congruent to angle ACB. Example 6, ADC is going to be congruent to angle ABC. Opposite angles will always be congruent. And lastly, segment AB. What segment will that be congruent to? Well, it's part of the parallelogram. Opposite sides are congruent. It's going to be congruent to segment DC. And lastly, to kind of put some numbers into play here, if we've got a parallelogram, PQRS, we know that PQ is 5, that QT has a length of 3, and that angle QPS, right here, this angle, has a measurement of 70 degrees. We could use that information to figure out the measurements of the following segments and angles. SR, opposite sides are congruent, would also be 5. Angle RSP, that's supplementary to the angle that we were given. So if that angle's 70, its supplementary angle's got to be 110. Segment QS, the entire diagonal here, if this is 3, then ST also has to be 3 because the diagonals are bisected, which means that QS would have an overall length of 6 units. And lastly, measure of angle QRS, it's opposite the angle that we were provided. So if that angle is 70, this angle down here is also 70 degrees. So just some information on parallelograms. We look forward to seeing you in class. Hopefully you've got a chance to watch the video, and hopefully you enjoyed some of my awesome techniques of teaching and the lovely colors distributed amongst the notes. Have a great day.